Welcome, welcome, welcome. In this video, we're going to discuss something called polyalphabetic ciphers, and in particular, we're going to start with the key phrase cipher. In a previous video, we talked about monoalphabetic ciphers. So what were those? They used the same substitution across the entire message. So an example of that was when we used the linear code. One of the things that the kibitzer could do is do a frequency analysis. Say, how many times did Z appear? And, oh, it appeared very often, and that's probably the letter E. Well, in polyalphabetic ciphers, we kind of fight against that attack because the substitution may change throughout the message. So just because Z appears a whole lot, it doesn't mean that Z is all of a sudden E. It could be different things throughout different parts of the message. So one example of this is the key phrase cipher. Some people call this the veneer cipher. I'll stick to the key phrase cipher when I refer to it though. So what it does is it takes the Caesar's code or generalized Caesar's code and does different shifts throughout the message. And often we use a key phrase to do these shifts. So for example, we could choose the word ham, and that could provide the different shift values, like we shift by H, and we shift by A, and we shift by M. So we'll repeat, if we're using ham, over and over and over until it matches the length of our plain text. And we'll use this grid over here on the left-hand side to help us out. Okay, so let's do an example. Let's say we wanted to encode the word student. How would we go about doing this? So let's start by just writing our plain text down on our page. Okay, so now that we have that, we use the key phrase, or in this case a key word, over and over and over until we run out of letters. So we have ham, and then we can repeat ham again, and then we run out of letters at an H, and that's just fine. You don't need to complete the word again. So to do the encoding, we use the table over here. So on the table, first we have the alphabet listed just in that first column. And then the alphabet is listed again in the other columns, but instead of starting at A, we start at H, A, and M. So it'll represent those corresponding Caesar shifts. So we want to encode the letter S. So we'll look up S on our table, and then underneath the H, we have a Z. So for this first one, it encodes to Z. So we'll repeat that process, and we'll look for the T. So there's our T. The T is underneath the A, and it just gives us T back again. Now, of course, with the letter A, there's really no shifting at all. That would be a Caesar shift of just 0. So we can go ahead and write maybe E underneath that A as well, because the E isn't getting shifted anywhere. But let's continue on. So for the U, we would look up U in our table and say, okay, the U is underneath the M, so it would encode to G. So we get a G right there, and then continuing along, looking up D in our table, underneath the H, we have a K, so we'll put a K value right there. Then looking up N in our table, underneath the M, we have a Z, so we get another Z here. And then finally, for the T, it will encode to an A. So we get zjkza as our gibberish that represents the ciphertext. So there's our ciphertext that we would send away. And we are also kind of seeing the notion of a polyalphabetic cipher already. If you notice, okay, there's a Z and there's another Z, and this Z is representing N, but this Z over here is representing S. So it does throw a wrench in the idea of just using the frequency analysis attack. It's not going to work so well anymore. Okay, let's play the role of the decoder now. Let's try to say, we've got this gibberish that's been sent to us. How can we decode it? So let's write it down on our page. And again, we'll repeat writing ham on the top over and over and over. All right, so now let's do some decoding. So this time we'll say, okay, we're trying to decode J and we need to look underneath the H. So we look underneath H for a J and we find a C. So the first letter in our message is a C. So next we'll look for an E underneath the A, and that will decode to E. Just like before, the A is not doing any shifting at all, so we can copy in the letters there. So we have an E and another E and a D at the very end. So looking underneath the M, we will search next for a Z. So we search for the Z and say, okay, it decodes to N. Okay, so we write N there. And underneath the H, we would look for an A, and it would decode to T. And underneath the M, we would look for the D, and it would decode to R. And then finally, we would get an E at the end there. So the plain text word that we're looking for here is centered. And if we put it together, we have a little message here that says student-centered, a style of teaching that we all like. So speaking of which, it's your turn to give this a try. So give this a try. See if you can use the word pepperoni to decode this message down here. I'll give you the answer in a moment. Okay, so let's look at the answer here. So if we look at our plain text that we got out of this, it might not look like very much right away, but if you look closer, it does actually say something. We have Chicago, and then style, deep dish. So this is an extra added thing that is sometimes done with cryptography. Sometimes we don't put the actual spaces where they belong. I suppose that adds some security level to this process of sending away messages. And also sometimes there's a little bit of consistency that goes along with that. Like we have blocks of size 5 for all of the letters that we're sending away in this particular example. Well, that's a very nice lead-in to the next cipher that we're going to look at, which is called the Hill cipher. So in the Hill cipher, that's the main idea, is to separate it into different blocks and then encode/decode each block one at a time. So thanks so much for listening, and we'll see you on the next one.